Patron Robert Williams asked, what would be the Roche limit of 2 white dwarfs? Hello again, astronauts! Welcome to Bad Astra, a wacky science channel where we learn about physics with more costume changes than math. On Wednesdays, we release videos ranging from the Bad Answers series, where we answer viewer-submitted questions, to interviews with scientists about their research, to science-related music videos when we're feeling extra ambitious. Our main content comes once a month in the form of deep dives on scientific topics, from the life cycle of stars, to vaccines, to the history of the universe. Please remember to like, comment, subscribe, share, and check out our Patreon for early access to videos and exclusive content. The Roche limit, or Roche radius, is the distance from one body at which the smaller body orbiting it will disintegrate due to the external tidal forces exceeding internal self-attraction. The gravity, or the warping of space by an object, is stronger closer to that object's center of mass. Tidal forces are the difference in gravitational force affecting one end of an object and the other end. Technically, when standing up, your feet experience a stronger gravity from Earth than your head does, but not by a noticeable amount. Every object has internal gravity, which attracts all of its mass together. That's why most celestial bodies of a certain size are roughly spherical. Within the Roche radius, the smaller body's own gravity isn't enough to hold it together, and it is pulled apart by the larger body. Remember that this limit only applies to the gravity holding objects together. An artificial satellite held together by steel beams and welding can orbit inside its Roche limit without breaking up, but any debris just sitting on the satellite will be lifted away by tidal forces. Following Newton's theory of gravity, because general relativity is hard and we're not going to be looking at anything heavy or fast enough for the difference to really matter, we can actually derive the Roche limit for 2 objects. Since I don't have the energy for a costume change, we're going to skip that math and give you the final equation. The derivation's on Wikipedia, and I'll link it below if you're into that type of thing. For the rest of you, the Roche radius, or d, is dependent on the radius of the primary or larger body and the ratio between the densities of the larger and smaller bodies. Robert's original question was about white dwarf stars, so now is where I should look up the radius and density of white dwarfs. But here's the thing, I'm lazy, and according to this equation, I don't have to. Since both stars are white dwarfs, I can assume they have the same density, which is 10 to the 9 kilograms per meters cubed for an Earth-size white dwarf. Okay, fine, I was more curious than lazy while researching this. And just cancel the densities out to 1. 2 to the 1/3 is 1.26, so the Roche limit for 2 white dwarfs is 1.26 r, or 1.26 times the radius of the larger white dwarf. But we're saying they're the same size, so the radius of either. This means that in order for 2 white dwarfs to get close enough to rip each other apart, the distance between them would have to be no more than 1/4 of their respective radiuses, or around 1,600 kilometers for Earth-size white dwarf stars. Note that I'm not factoring in the effect of centrifugal forces, because they only really matter for roughly circular orbits. But feel free to check out that derivation on Wikipedia as well. Say goodbye. Astra out.
Ad Astra, to the stars, to the stars. stars.